My name is Muhammad Mahadi bin Syukur. Now I would like to present about the introduction of the project. This project covers the design of a story steel frame building. All the detailed design will be explained for all element structures such as an internal column, truss member and connection types. We can see the structural layout for our project and many type of brace member and type of connection that we can refer or use for this project.
My name is Marham and I will continue the presentation. I will present about the specification of sections and selection of load applied on our Step Pro. We have dead load which applied on whole structure is 0.61 kN per meter. For our dead load roof, we have ceiling and service load which apply on bottom chord is 3.05 kN per meter. Roof tiles and purlin applied on top chord is 1.53 kN per meter. For steel decking which apply on top chord is 1.22 kN per meter. For our live load roof, we have variable load which 1.5 kN per meter squared, which apply on top chord will become 9.15 kN per meter. For wind load which apply on top chord, we have 4.0 kN per meter. The size that we use in our Step Pro is column UC shape, which is 254 times 254 times 107. For truss, we have rectangular hollow section, which is top chord, bottom chord and internal members. We use same size, which is TUB 120 times 80 times 10. Next, I will explain the combination of load considered for this study. We have two types, which is serviceability limit state and ultimate limit state, which is for our serviceability limit state, we have QK, WK and Win. For ultimate limit state, we have QK, WK, minimum and maximum, which total out we have 7 type of limit state. For parameter assigned for Step Pro code use was EN 1993-1-2005. First, deflection length or maximum allowable local deflection DFF is 200 mm. Second, the minimum required depth D-min is 200 meter. Third, ultimate tensile strength of steel FU is 407,800 kN per meter squared. Fourth, yield stress of steel is 253,200 kN per meter squared. 5. National Annex NA use is Malaysia standard. 6. Grade of steel SGR is S275. From this specification and section, we can get the forces that we can use to analyze and design of steel structure.
Explanation about design of bottom chord. We get the design value of tension force NED from the Step Pro. Then we do the calculation and find the value of A. Then from the EC3, we use the size that we choose for rectangular hollow section. Then for the verification, we must find the design plastic resistance. Then after that, we find the value for the design ultimate resistance NURD. Based on that, we can see the NTRD is more than NED and it is okay. Then we assume the both sides and the diameter hole, and after that we calculate the pitch and the beta 3, and after that we calculate the NURD, that is tension capacity, and from that we must find the A net first, and then we can use the value in the formula, in the NURD formula. So based on that, we can conclude that the value is more than NED and is okay, so the proposed size is acceptable. Now is the explanation of design of top chord. from the step pro analysis, we can get the value of NED, the design value. Then we use or propose the size for the rectangular hollow section, same as bottom code. For the section properties, we refer from EC3, the H, B, T area, LZ, LY. And next, for the calculation of class of section in uniform form, we can refer from table 5.2 sheet 3, and we can conclude that the section is at least class 3. Next is the calculation resistance of cross section, and we proceed to the buckling resistance of member. The length system is calculated, and next is for the design buckling resistance of member, NBRD, NBZRD. So we calculate the slenderness, we find the value to determine reduction factor. We can refer to table 6.1 and 6.2. The factor is, we use equal to A equal to 0.34. So after that, we find the value of the buckling resistance, and we conclude that the value is more than NED and is okay, so the proposed size is acceptable.
For vertical member, max tension force is 69.505 kN, max compression force is 420.540 kN. Tension member, it needs to satisfy NED over NTRD, which is it needs to be equal or less than 1.0. A is 254 mm cubic. Use 120 multiplied by 80 multiplied by 10L of RHS. Gross area is 274 mm cubic, which is more than 254 mm cubic. Verification of tension resistance is equal to 75.35 kN, and URD is equal to 106.038 kN. So to verify it, NED over NTRD is 69.805 over 75.35 is equal to 0.93, is less than 1.0, so the proposed size is acceptable. For incline member, NED is 42.54 kN. You use 120 multiplied by 80 multiplied by 10L of RHL, same as tension member. Suction member, H is equal to 120 mm, B is equal to 80 mm, T is equal to 10 mm, area is 274 mm cubic, IZ is equal to 313 mm, IY is equal to 609 mm. Class of section in uniform compression is equal to 0.92. HT is equal to 10, while 11.5T is equal to 10.58. Resistance of cross section is equal to 75.35 kN. Continue with buckling resistance of member in plan of truss. LER2 is equal to 1242 mm, lambda 1 is equal to 86.8, lambda 2 is equal to 0.05, O2 is equal to 0.48, X is equal to 1.04, N62RD is equal to 78.36, which is more than NED. Buckling resistance of member out of plane of truss. LCRY is equal to 1380 mm, lambda 1 is equal to 86.8, lambda bar Y is equal to 0.03, OY is equal to 0.47, X is equal to 1.06, NB1Y1RD is equal to 79.871 kN, which is more than 42.5 kN. For design of purlin, distance between purlins is 154 mm, spacing between truss is 6100 mm, design action is equal to 26.8 kN, combined action is equal to 36.8 kN, sec P is equal to 90.82 cm cubic, D is equal to 135.56 mm. Assume set road assigned on the middle of purlins, B is equal to 50.83 mm. Therefore, use single angle 200 multiplied by 150 multiplied by 5L 2 multiplied by 147 cm cubic. Check deflection. Deflection is equal to 26.45 mm. Allowable deflection is equal to 30.5 mm, which is more than 26.45 mm.
My name is Anis Arisha binti Nur Azmi, and I will present about the steel column design for our project. Firstly, from step pro analysis, the value of NED that we get is 68.87 kilonewton, and the size proposed from the step pro analysis is 254 times 254 times 107 UKC, and from the size we refer to the Eurocode, and the value of H is 152.4 mm and the value of B 152.2 mm. And then we'll check the weak axis, Z axis, and then next we based on table 6.2 we use curve C from figure 6.4, and we calculate the value of NBRD using the formula S times A times Fy divided by lambda, and the answer is 433.62 kilonewton, and which is okay because the value is bigger than the value of NED, which is 68.87 kilonewton. Next, we'll calculate about the proposed size design for axial only, and from step pro analysis, the value of NED is still same, which is 68.87 kilonewton, but we propose new size of column, which is 152 times 152 times 23 UKC in grade 275. We propose new size because we want to know the difference between the proposed size by step pro and the difference between the proposed size by our group. And lastly, we get the result of buckling reduction 0.85 less than 1.0, and which is okay. Next, we calculate the NBYRD for this axial only, and the answer we get is 441.65 kilonewton, more than the value of NED, which is okay. Thus, the buckling will occur at Z-axis first due to amount of NBRD of Z-axis less than Y-axis. Next, the proposed size will design for axial plus bending, and firstly we find the cross-section classification, and the section is not in class 4, and then we will calculate the nominal moment, the buckling resistance, and based on table 6.5 we use buckling curve A, and then from table 6.3 the lambda LT is 0.21, and then for the final answer we get 0.159 less than 1, which is okay. So the use of 152 times 152 times 23 UKC in grade still is satisfied. Lastly, we will calculate the proposed size design for biaxial bending, and firstly we calculate the maximum bending moment, which is MZED. The answer is 3.043, and then we design bending resistance, so we get the answer 22.03, which is good because it is less than at least greater than the maximum bending moment. And then we calculate the shear resistance of cross section, and lastly the answer is acceptable for load parallel to flange.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syairah binti Jamal Lail. I'm going to present about the connections of this project. There are three types of connections involved of this project, which are column to base, truss to column, and truss to truss. For column to base and truss to column, there are four check requirements where check 1 is required area, check 2 is effective area, check 3 is plate thickness, and check 4 is welds. For check 1, to find the required area, we use the equation of NED over FJD. For check 2, we use equation 4C squared plus CP column plus A column to find the value of C. For check 3, to find TP mean, we use equation C square root 3 FJD gamma MO over FYP. For check 4, we use equation FVWD equals to FU over square root 3 over beta with W gamma M2. For truss to truss, we will find the shear resistance and bearing resistance. For the first type of connections, which is column to base, the value of NED we got in step pro applications is 68.87 kN. We use the base grade is size 275, which is 300 times 300 times 90, and the column grade is size 275, which 254 and 2 times 254 times 107. The value of VED is 8.914 kN. By assuming the value of FED is 70 Newton per millimeter square, we got the value of A required is 4051.18 millimeter squared, which less than A provided of 90,000 millimeter square. The value of C from equation A effective equals to 4C square plus CP column plus A column is 149 millimeter. To ensure that there is no overlap, C has to be less than half of the depth between flange. So we use equation H minus 2TF over 2, and we got the value of 67.3 millimeter is less than the half of 149 millimeter, which is 74.5 millimeter. So the value of C is valid for 149 millimeter. For TP minimum, we use the value of C and got 70 millimeter is more than 69 millimeter. The value of FWRD gamma M effective is 334 kilonewton, and the value of VED is 8.914 kilonewton, which is less than 334 kilonewton, and it is accepted. For the second type of connection, which is truss to column, the calculations remain same to the first before. The truss size is 275, which is 200 times 200 times 19, and the value of NED is 68.87, and the value of VED is 5.447 kilonewton. The value of A required is 4051.18 millimeter square, which is less than A provided, which is 40,000 millimeter square, and it is okay. The C value is 149 millimeter. The C value is valid, and the TP minimum is 70 millimeter more than 69 millimeter. And lastly, the FWRD gamma L effective is 334 kilonewton, and the VED value is 5.447 kilonewton, which is less than 334 kilonewton, and it is accepted. For the connection of truss to truss, the shear resistance per bolt FVED, we got 47 kilonewton, and the bearing resistance by using FBED equations, K alpha FUDT over gamma M2. For N bolts, we got 0.606. For minor bolts, we got 0.66. For H bolts, we got 2.5. And the backward calculation using VED is by using bearing resistance. For N bolts, we got 62.95 kilonewton, and for inner bolts, we got 68.11 kilonewton. The resistance of joint spike column to base is controlled by the strength in shear. Therefore, the resistance of tension spike in governed by shear resistance of bolts is 2 times 11.14 kilonewton equals to 22.28 kilonewton is more than 8.914 kilonewton of VED. So that's all for connections.
For the conclusion, the single-story steel building was designed successfully according to the reference and information that we used for this project. The section chosen for purlin, roof truss member, beams, and column are adequate to support the loading imposed on the building. So the concept of designing for steel structure for this project was fully understood by every